So in the previous video we were solving systems by elimination, and we had systems where we already had a variable that was going to cancel itself out. So now we're going to step it up a little bit with our elimination. So let's say we had negative 3x plus 2y equals 23, and 5x plus 2y equals negative 17. Okay, so this is very similar to what we did before. We want one of our variables to eliminate. And the last video, we were looking for variables that had the same number but opposite signs, so they would just cancel each other out. Well, in this one, we do have our y values that have the same number, just not the opposite sign. So this is where we're stepping it up a little bit from what we did on the last video. So what you want to do is, since they already have the same number, we just need... Oh. Alright, so what we need to do with this is, since our y values have the same number, but both of them happen to be positive, we need one of them to be negative so they'll cancel out. So what you want to do is either multiply the top by negative 1, which means you can change the sign basically of each part, or you could multiply the bottom one by negative 1. It really doesn't matter which one you choose, but what most people will realize is that if you choose one that has a bunch of negatives or minus signs, it's going to change them to plus, and it's going to make it easier to work with. So in this one, the top one has a negative number, and so does the bottom one. So it really doesn't matter. I'm just going to multiply the bottom one by negative 1, because by doing so with this one, the 17 is a larger number, so it just makes it a little easier to work with. So now my new equations, what I would recommend doing is off to the side, write your new equations. Our top equation did not change. Okay, so I'm leaving that one alone. The bottom equation now, because I'm multiplying everything by negative 1, it's going to change its sign. So it's become a negative 5x, it's going to become a minus 2y, and it's going to become a positive 17. Now we can do our elimination like we did in the last video. In this one, our y values are going to cancel, and negative 3x and negative 5x would give me negative 8x, and 23 and 17, which would give me 40. So all I'd have to do is divide them both by negative 8, and I get negative 5. Okay? So now we have to do the same thing we did in the other ones. We're going to pick one of the equations. It does not matter which one. It could be the original first one, the original second one, or even the one after you multiplied by negative 1. It really does not matter. I think in this one I'm just going to pick the top one. So the top one was originally negative 3x plus 2y equals 23. And since my x is equal to negative 5, I'm plugging in a negative 5 in for my x value. Sorry, I'm changing colors. Plus 2y equals 23. Well, negative 3 and negative 5 is 15. Plus 2y equals 23. I have to minus 15 to both sides. I'm starting to run out of space. So those are going to cancel, so I get 2y. And let's see, 3, that should be 8. So in this case, my y is equal to 4. So the elimination we're going to look at, we're going to do just a couple more examples of these, but all of them are going to have either the x's or the y's with the same number and sign. So we're going to have to pick one of the equations and multiply it by negative 1. Do realize that you may choose, let's say, the top equation and multiply by negative 1, and your friend might choose the bottom equation. It's fine. It does not matter which one you choose, whichever one you think is going to make easier by changing its sign. So if you need anything from this screen, go ahead and get it. I'm going to clear it off. Alright, so now we're going to try negative x minus 7y is equal to 9. And we're going to try negative x plus 9y is equal to negative 23. Cannot write well today. Okay, there's a negative 23. There we go. Alright, so with this one, again, our x's actually are the same, they have the same number, but they both happen to be negative. I need one of them to be positive. So it does not matter which one you multiply. I think for this one I'm going to multiply the bottom just because it gives me a negative 23. You could have multiplied the top as well, it really does not matter. I'm just going to do this one. So again, what I recommend is once you do this, go ahead and write both your equations again on top of each other. So my top equation didn't change. My bottom equation is now going to become a positive x, a minus 9y, and a positive 23. So now I have the same sign. I can go ahead and do my elimination. In this one, my x's are going to cancel. So negative 9 and negative 7 give me negative 16y. And then 23 and 9 is going to give me 32. And all I have to do now is just divide by negative 16. So my y value in this one's going to be negative 2. Alright, so now, again, it doesn't matter which equation you choose, the top or the bottom one. I'm going to choose the top one, I think, because it has a little bit, well, actually, you know what? I'm going to change my color here. It does not matter if you choose the original top, the original bottom. I'm actually going to choose this one right here. Okay? You can choose the one after it's been multiplied by negative 1. That one doesn't have a lot of negatives in it, so I'm just going to choose that one. You could have chose one of the original top ones, it doesn't matter. On this one, my y value is negative 2. So I'm just going to type in a negative 2 in for my y value. So in this one, negative 9 times negative 2 is a positive 18, equals negative 23. Oh, I just realized that. I accidentally wrote negative 23. It's supposed to be a positive 23. It does help if you write the equation correctly. Alright, so now we want to minus 18 to both sides. So I get that x is equal to 5. Alright, so we're probably going to go through and look at one or two more examples of these. There's actually more complicated elimination problems that we'll get to the next time, but I really want you to get kind of these skills mastered with some of these easier ones first. So if you need anything from the screen, go ahead and get it. I'm going to change screens. Okay, so this one we're going to do 12x plus 2y is equal to 30. And we're going to do 7x plus 2y is equal to 10. Okay, now with this one, again, my y's have the same number, I just need opposite signs. So it doesn't matter if I multiply the top one by negative 1 or the bottom one. I'm actually going to choose to multiply the bottom one by negative 1 because the top numbers have a lot of negatives, so I think once that's simplified out, it's going to make it a little bit harder. So my original top equation is going to stay the same. My bottom equation, everything's going to change signs. So this can become a negative 7x minus 2y and a negative 10. So now I have my y's have an opposite sign. I can go ahead and do my elimination. 12 minus 7, which gives me 5x. My y's canceled. And 30 and negative 10 gives me 20. So if I divide both of them by 5, I get that x is equal to 4. So there's one of my variables. Now, remember, for your second equation, you can pick either of the original equations that you began with, whichever one looks easier to you, or the one after multiplying by negative 1. In this one, I'm actually going to choose this one right here, my original one before I multiplied it by negative 1, just because it's got nice smaller numbers in there. There's no negatives. It's going to be a little easier to find my variable for. So in this one, I know that my x value, change my color, x value is equal to 4. So I just substituted in a 4 for my x. So 7 times 4, which gives me 28, plus 2y equals 10. I have to minus 28 to both sides. So I get 2y is equal to negative 18. So I divide by 2. I get my y is equal to negative 9. Alright, so I think hopefully for the most part you have the idea with these. Really try to get this elimination stuff mastered. Elimination is going to be your most commonly used one in Math 1 for systems. And they do get more complicated than this, which we will start the next time. But good luck!